Good.
Alright, so still doing trigonometric integrals using the first case. Example 3, we have the integral of sine of t to the 5th power times cosine of t cubed dt. So because we're doing case 1, we have to, we're going to solve this integral using 3 steps. Our first step is to save one of our cosine functions. So we're saving one of our cosine functions. That's going to give us, expanded, that's going to give us sine of t to the 5th power times cosine of t squared times cosine t dt. We always want to remember to keep our saved cosine function next to dt. So now we're going to move on to our second step, which is to use our cosine identity. Which we know is when cosine squared of t is equal to 1 minus sine squared of t. So now we're going to take our identity and plug it back into our integral, which is going to end up giving us the integral of sine of t to the 5th power times cosine squared of t we just found is equal to 1 minus sine squared t times cosine t dt is the rest of our integral. Alright, now we're going to move on to step 3. And step 3 is to solve this integral using u substitution. Alright, now we're going to let u be equal to sine t. Which means that du is going to be cosine of t dt. So now we're going to take our variables of u, plug them back into our integral, which is here. Because we only let u be equal to sine of t, and we have sine of t to the 5th power here, we're going to end up with the integral of u to the 5th times 1 minus, 1 minus sine squared of t. It's going to give us u squared. And then the rest of our integral here is cosine t dt, which we found up here is equal to du. So now we have this. So we're going to make it easier and distribute our u to the 5th power, which is going to give us u to the 5th power times 1 u to the 5th minus u to the 5th times u squared is equal to u to the 7th power. And then we can't forget to bring our du down. So now we're just going to solve this integral using our basic knowledge of antiderivatives. Antiderivative of u to the 5th power is u 6 over 6 minus u to the 8th over 8. And then this is an indefinite integral, so we can't forget to put our plus c at the back of that. So now we don't just stop here, we have to go back up here, find what we set u equal to, and plug that back in to our answer. So we end up with sine of t to the 6th over 6 minus sine of t to the 8th over 8 plus c. And then we're finished, and this is our final answer.